Please welcome Lynn Neese.
All right, I think we have our panelists coming up now. Got from Danfoss, Anne Hoyer-Nygaard. We've got Mark Dauber from Carbon3ai and Pascal Leclerc from HPE. So what we're going to talk about today, first of all, let's just do the quick intros. Again, you can see all of us here. I think I introduced us. So, and I think we'll have people give a brief introduction of themselves and what your role is.
Okay.
So,
Well, thank you so much for having me here. I'm very excited to talk about this topic. I'm Anne, and I work at Danfoss. I'm heading our strategic partnerships out of IT, meaning that I'm working with a lot of technology and IT-heavy vendors. One of them, so lucky, being HPE.
yes.
Hi, thanks for having me here as well. I'm Mark Dauber, so I'm the co-founder and the Chief Energy and Infrastructure Officer, it's quite a mouthful, for Carbon3ai.
Thank you. So I'm Pascal Leclerc. I'm leading at HPE what we call IT sustainability and data center modernization business. So this is everything related to data center and how to optimize data center in a better IT sustainability way.
Excellent. So the purpose of this panel is to discuss what's coming about in big changes related to data centers and sustainability. And of course, data center sustainability go hand in hand in a lot of the projects that we get involved with, and many of our customers are obviously involved with. And there are three key things that are happening right now that indicate big changes are underway. And I think everybody knows this already, right? But first off, AI and its impact on the physical infrastructure, huge impact on the data center facility. The second point is you can't escape your facility somehow being impacted by this because of the concept of sovereignty, both at I'll say a national level, but sovereignty at an enterprise level. If you're going to host AI agents that somehow do things productive in your enterprise, there is an impact to your owned infrastructure for this. And that's what that second bullet is about, right? To get purpose-built flexibility, you will have to host some of this infrastructure, and AI is affecting that infrastructure and the amount of physics you've got to host. And then the third point here is there have been a lot of changes in how data centers are built and maintained in the modern, recent EPOs, we'll say. And so we'll discuss more of that now as part of this panel, okay? So we're gonna start by allowing Anne to discuss our heat capture and Danfoss.
Yeah, thank you so much. Well, again, good afternoon, everybody, and thank you so much for having us. For those who don't know Danfoss, we are a 10 billion euro Danish engineering company. In short, we create solutions that increase productivity, reduce emission, and lower energy consumption. You can find our technologies, you can find our work everywhere. We're in refrigeration, we're in heating, in motor control. You can find us in renewable energy, such as solar and wind. But sustainability has been in our DNA since we were founded in 1933. And today our purpose is more clear than ever. We help our customers decarbonize. We engineer solutions that work for a better tomorrow. Right now, it's especially important within energy-intensive industries, such as data centers. Now, since we're here at Discover, let me bring you a real-world example. With HPE, we are building or have building and continuously build our own data centers in our headquarters in the south of Denmark. This is state-of-the-art with AI mod pods and with Danfoss energy efficient solutions. And Pascal is nodding because you also know this very, very well. HPE, of course, delivers the IT services, and we deliver our innovative heat recovery solutions. Now think about all the surplus heat that is pouring out of the servers in your data centers. Instead of just wasting it, letting it out in the air, capture it, use it. We capture up to 90% of our own surplus heat in our data centers. We feed it directly into our campus, which is next to our data centers, and what's surplus from that is then fed into the local district heating network. So now we're supplying to the surrounding environments as well. So the servers that are processing our information today, they are literally heating the homes and the businesses down the street this evening. This dramatically reduces the need for fossil fuels. So this is important yesterday, and it's important today, but it's even more important in the future. You cannot have attended a session here without talking about AI. And AI has the side effect of increasing the demand for data, speed, and processing. This puts enormous pressure on our digital infrastructure, and it drives up the energy consumption. This isn't just about being green, it's about building digitally resilience. It's about working towards a world that can handle future demands without failing. But the technology that each of us are providing, even though it might be very brilliant, cannot stand alone. We need to work together to truly work towards competitive decarbonization. So when we're collaborating partners, just like HPE, we can scale our operations and we can faster meet that increasing demand for both speed and sustainability. So we're working on focusing on energy efficiency and heat reuse, and we help our customers thrive together, all while we're navigating this increasing regulatory pressure to decarbonize as well. So in this journey, we are turning sustainability from a cost into an advantage and potentially into a revenue stream. And as I mentioned, and you see in my title, partnerships is very core to what I do. So of course, partnerships is absolutely critical in this. We cannot tackle it alone. We need to partner up and join the mission in order to receive these goals. We have seen very long that we're very siloed. We have technology experts who are working. We have building experts that are working siloed, but we do need to have joint goals in order to unlock the next levels of efficiency. We need to break down these silos. It really improves what we're doing, is really improving the efficiency. We were talking a lot about energy efficiency. Now we see there's a little bit of shift in the narrative. It's not so much about green. It's not so much about sustainability. It is, though. But it's because we're doing it in a smart way. We're doing it to focus on efficiency, and efficiency benefits everybody. It cuts operating costs, and it future-proofs our investments. But more than that, it also creates a circular economy. And we do have a lot of customers that see the benefit in that. So this is now, and this is how, that we are all building the infrastructure of tomorrow. We're working together, technology leaders, energy specialists, and utility companies. We can work together to facilitate a fast, very efficient, and resilient symbiotic community. In short, we engineer solutions that turn waste heat into sustainable energy tomorrow. So, thank you for listening. Before you close off from my talk here, my call to action is, let's move beyond managing heat and start harvesting heat. Let us together build the next sustainable infrastructure. Thank you.
Okay.
All right.
Next, I think
Mark, you're going to talk about Carbon3ai?
No.
Oh, no, this is Pascal.
Pascal, actually.
These are our mod pods.
So, no issues. Thank you, Lynn. Sorry. So, yeah. So when we talk about all those transformation journeys that our customers are getting through, of course, this is about implementing new use cases currently. So everybody's talking about AI, you know. So when we talk about AI, this is a marvelous concept. By the way, it can be seen as the devil, can be seen as the even, but at the end of the day, we need to implement new technologies, okay? So what about those new technologies? This is sometimes considered as a breakthrough in terms of technologies in an existing data center, because most of the data centers, they have not been designed, they have not been built to run those new use cases, those new technologies. So we will just take some simple example that is about cooling technologies, and heat reuse definitely is fitting really hand to hand with the cooling technology. So those new use cases are using new technologies that are more and more dense. At the end of the day, we are talking about, let's say, several tens of kilowatt per rack. Even now, the upper limit that we are reaching that are already in production. We are talking about 400 kilowatt per rack, you know, with our big Cray EX4000 already available in production, you know. We are talking now of the next generation infrastructure featuring next year 600 kilowatt per rack. And we are already preparing for the next generation, 2027, when we'll be introducing 1 megawatt per rack. So this is massive challenges in all the data center to be able to run this kind of technology. So new technologies like direct liquid cooling are worth implementing because, I mean, this is even mandatory. You cannot cool by air this kind of IT technology. So typically what we are doing, we are working with our customers to design and implement those new technology, and specifically with new kind of data center. I mean, the fastest growing kind of data center, this is what we call modular data centers. At HPE, we got a solution for that we call AI Mod Pod, modular performance optimized data centers. And those data centers are natively designed to support this kind of direct liquid cooling technology and what we call those fat boys or those big boys, you know, big racks and so on. So together with that, of course, this means that we need to design and implement those data centers that will meet all the requirements with 4 major key elements to consider. The first one, of course, this is about technology, liquid cooling technology, as we said. The second one, this is the rapidity and the speed of implementation, okay? And Danfoss, as well as Carbon3ai, they had those challenges to implement in a couple of months those new data centers. We are talking about 7 to 8 months versus a brick and mortar data center from the design to the build to the commissioning that will take 2 years. Okay, those new use cases to implement, all the customers are facing that. They cannot wait 2 years to make the new IT system running. Okay, it's just not possible. The third thing is flexibility. Because of the modularity, this is like Lego box. Lego box, Lego games, you know, you just implement new module when it is needed for what purpose it is needed, okay? And the fifth one, of course, we are talking about sustainability. So sustainability first, this is about energy efficiency. When you get to direct liquid cooling, you can have saving up to 83% of the energy that the data center is using, I mean, kilowatt hour, for the cooling of the IT infrastructure. There is definitely no comparison between air cooling and liquid cooling. 83% savings in terms of energy, so in terms of carbon footprint. Then also when we are talking about those liquid cooling technology, either hybrid, as it is shown here on the slide, or what we call also fanless, meaning 100%. All the IT components in the server are cooled by liquid. This is fanless, not a single fan, you know, turning. In this kind of technology, you know, definitely either hybrid or fanless. If you get to the energy efficiency that you can gain with direct liquid cooling, from the other side, you use liquid. This liquid will be inserted in the server at a temperature that can be 30, 35 degrees in, 40, 45 degrees, even in some cases 50 degrees out. So with Danfoss, when you get water out of the server at 45, 50 degrees, this is a perfect use case to capture this heat and present this heat to whatever heat reuse use case. Can be building heating system, can be to inject into a district heating system, can be to inject into agricultural, can be injected on the shop floor because the shop floor needs liquid cooling. No, sorry, need heat. Okay.
Yes.
So this is it. So definitely, this is a perfect use case, for better sustainability because it's consumed less electricity to cool. And by the way, this is a perfect use case to reuse the heat coming out from the data center. And if most of you are from EU or in the Europe, most of the countries now and in the EU, there are new mandates, new directives from the EU, like the EED, the Energy Efficiency Directive, and so on. And some countries at the country level have already, let's say, issued new laws, meaning that all new data centers that are supposed to be up and running in the next couple of months, starting January 1st, 2026, for example, in Germany, every new data center, if they want to get the permit to build or the permit to operate, will have the mandatory, let's say, requirement from the EU to implement each recovery system. So no way to escape. Then, of course, this is about other things. This is also about monitoring the system. So, for example, digital twin now is a must in order to better operate and to better manage the data center. You may have the best rocket to fly to Mars, but if you have not the good control system, the good reporting system, the good dashboard, you will fail, you will crash. So this is about it. Digital twin is something that is now embedded also in our AI modpod system in order to better operate and manage the modular data center. Other technology like what we call the adaptive cascade cooling, this is very useful to put together both the air-cooled system and the liquid-cooled system into a single mesh in order, I would say, to take benefit from one technology for the other technology to better optimize the cooling plants. Okay? If you want to get more details on that, please come on the show floor on our demo 216, and we can show you how it will work.
We even have 50 degrees C water somewhere right now, kidding.
Absolutely.
Okay.
All right.
Thank you. Thank you. Hi, everyone. So I'm here to talk to you about Carbon3ai, relatively new business. I think before I go into it, I just wanted to explain the why we're here. It's clear that AI is going to redefine our industries. And I think now the question is, how do we build that out in a sort of sustainable, scalable, sovereign, future-proof way? And that is actually why Carbon3 exists. It's not just to deliver AI capability in the UK, it's to deliver AI responsibly. So a little bit about the business. We actually founded earlier this year off the wings of a UK-owned 100% renewable baseload power generation business. So these are real sites, real locations across the UK. And we looked at the kind of barriers that exist, particularly sort of in the UK, regarding grid connectivity, high power prices, slow plans to deployment with permitting and planning, and actually very little kind of sovereign and sustainable infrastructure available to deploy AI. And we realized that we were sat on part of the answer. So our sites are actually all grid connected. They're onshore, they're scattered across the UK, and they're all powered baseload 24/7 by 100% renewable energy. And they're backed by renewable obligation certificates and REGOs. So what we're doing now as Carbon3ai is actually building that physical infrastructure on top. So on the sites and on top. So to date, we've actually, you might have caught it in the keynote, we've deployed a HPE private cloud AI, and that is being powered now 100% on renewable power. We've committed with HPE again to deliver 7 megawatts worth of the mod pods. So yeah, they're actively being installed as we speak. My phone's not gone off, so everything must be going pretty well today. So, and our objective is to bring V300s to market early next year. And what's sort of unique, and when everyone talks about sustainability, and it was sort of unique for us, is that this physical setup is going to generate carbon credits. So, you know, you're the business, you want to run a use case, and you can actually use our infrastructure, our services, to deliver those use cases with zero carbon impact. That's, you know, before you look at the sort of outcomes that those business cases actually might deliver. And this is real savings. This is not greenwashing. This isn't buying wind power from Scotland, a certificate for it, and importing it down in London. This is real, on-site, renewable power, directly connected to real AI infrastructure on UK soil. So for me, that's sovereignty, that's responsibility, and I think that's what a future-proof sort of AI ecosystem looks like. When we talk about sovereignty, and I'm not going to get into the many debates around sovereignty, we like to think about sovereignty as not just energy, it's about place. And what I mean by that is, we see the opportunity to bring deindustrialized sites back to life. Now, we've got 2 sites actually in the AI growth zones, and hopefully more that will follow in that. And these are sites that used to be powerhouses in sort of UK industry. You know, at the moment, they've been left behind. And I just think there's something poetic about turning sort of yesterday's waste into tomorrow's cutting-edge infrastructure, and breathing life into places that industry is left behind, transforming that energy into compute, into economic opportunity. And I'm not just talking about carbon or energy when we talk about that sustainability. We want to talk about jobs, skills, local growth, community revitalization. You know, we want to be part and want to see new technology hubs formed in places where heavy industry once stood. We want to bring AI value. We want AI to bring value back into those communities, not extract from it. And we want to grow in the UK to own this future, not just lease it from overseas. So in short, AI is inevitable. How we build it is not. And I think we've got a real opportunity to do this right with sovereignty, sustainability, and community embedded. And that is what Carbon3ai is here to deliver. Thank you.
Wow, very interesting. Very, very interesting. Mm-hmm. So we have over 20 minutes. We've got some questions prepared for the panelists, but if people here have some burning questions they'd love to ask, there are 2 microphones set up in these aisles. And while you're thinking of your tough questions, I will start asking a few. So Anne, heat capture, where we've seen it work, it seems to be great. It seems quite straightforward to do it. But for some reason, it doesn't get considered nearly as often as I would expect. So what are the barriers, and for people here considering it, what should they be thinking about?
Well, first of all, we're here today to talk about it because we are lacking education. Mm-hmm. It's not new technology. We've applied it in other industries, but using it in this context of data centers is fairly new for us in Danfoss. So we don't see it that often, but it is a topic that is increasing when we are talking about data centers, both refurbishing, but also building new data centers. So education is definitely the first point. How do we do it? There's also a thought that it has a very high financial barrier. We see that if you have the correct setup and you have an off-take of the heat, the ROI is 2 to 3 years. And then you can start making money off this. Again, there's education you need to understand. Then making sure that you have these off-takers is also part of, you need somewhere to dispose of this heat and this energy.
Mm-hmm. So finding the customers up front.
Yeah, if not yourself, if you don't have access to a grid, then what can you do? There are solutions, but you need to think about this.
And Pascal, I think question for you on a couple questions, which would be, I would say, monitoring and reporting. What are we doing in this area? And then secondly, I would ask you, for people here with an existing data center estate, what can they start thinking about?
Mm-hmm. Mm-hmm. So in fact, this comes from a kind of common status or assessment that we could do on tens or even hundreds of data centers running in the world. They are not prepared to have modern monitoring in order definitely to better monitor the operations condition of the data center. I'm not talking about BMS, building management system. This is really the upper layer to have a real and real-time status of what is happening in terms of energy efficiency and in terms of carbon emissions. Because it's not only about energy efficiency. I usually take this example, very old example. I can design and build you a very energy efficient kind of data center, what we call the PUE of 1.1, 1.2, but running 100% on diesel generators. Is it efficient? Yes. Is it carbon efficient? No. Right. But we are not only talking about carbon efficiency. If you read the press, if you read about all the new kind of protestation also coming, and we got to talk about that, clearly there are a lot of protestation all over the world when a new AI dedicated data center is built. This will consume all the electricity from the grid, no more electricity for the citizens. It will consume all the water. It will definitely reject massive heat, contributing to the global warming. So we are here to discuss that and to design new data center in order to, let's say, take all those issues into consideration. So heat reuse, definitely. Liquid cooling technology, definitely. Including sustainable power feed, as you are doing, with grids, with, let's say, using renewable energies and all that stuff. And as you perfectly say, not buying, green energy certificates, because everybody knows how to do that, really, bringing green energy to the data center. But then, what to do with that? You need to optimize the run, to optimize the operation, and you need to demonstrate, because at the end of the day, if you look at the EED and so on, so every year you will have to report as a data center operator what you are doing and how you are better in all those KPIs, like energy efficiency, like carbon emission and all that stuff, and water usage, etc. So, to make it simple, we have developed in-house at HPE a reporting tool that is a real-time reported tool that we call EER Premium, Energy and Emission Reporting Premium. And this tool is able to interface with whatever information system available in the data center, to put together and to, let's say, capture all the data in terms of whatever consumption with a very high value added. That is the vision by application use case, okay? So that you can have a vision of what is consuming your ERP, what is consuming your various AI use cases, what is consuming whatever application, commercial application, etc. And then, so gather all those data and issue, for example, a real-time report of what is consuming your AI use case like LLM, like agentic AI, in terms of carbon emission, but not only carbon emission, taking into account new KPIs that are now developed by the green grid. So like the water usage effectiveness, like the energy reuse effectiveness, etc. So in a nutshell, this is about that. This is to have a very top-class best practice tool in order to report in real time what you are using in your data center, definitely on all the KPIs.
Excellent. So Mark, question for you. First of all, is your baseload power behind the meter?
Yes, it is. Yeah, so it's mainly we've got a few bits of in the energy mix, but it's mainly biogas from waste, and yeah, it's behind the meter. Yeah.
So does that mean there's potentially an energy discount to users?
Yeah, the way we're setting up our business is in order to have a solid agreement between the energy business and the carbon business, and how we set that is going to be between the two businesses. But yeah, absolutely, it is a significant discount.
Very interesting. And then, what are some of the use cases that you see as early? Typically, when I've seen like new sort of colo type arrangements or as a service arrangements with data centers that follow the physics, things like network bandwidth and things like that are big limiters, or the SLAs. What are the types of use cases you're seeing interest now in Carbon3ai from enterprise customers?
Yeah, look, it's fair. You could probably guess I'm the energy guy, not the sales guy. But we've actually just launched with HPE an offering where we're going out to businesses and offering a sort of up to £50,000 value business case assessment for their business, and then full ROI calculations and cost of investment. So we're just seeing that sort of early engagement. We've had a lot of conversations with government, which we weren't expecting to have at this stage of our creation, and there's a lot of interest in that kind of off-grid resilience as well. So yeah, it's coming. So if you've got any interest, I can reach out to the sales guys, and we can assess where we can fit with the business.
And some of your behind-the-meter energy include energy that would have been wasted?
Yeah, absolutely. Yeah, it is. So if you can imagine, a biogas site, the waste, the gases in the ground, we've got to collect that. It's landfill gas. It's being created. We collect it at the same time it's being generated. We've got sites with solar as well, so we have got like a microgrid. I've not gone into that, but a sort of solar microgrid set up, and we're looking at installing some batteries. But at the moment, everything's sort of exported. Sometimes we get curtailed, as you've seen.
Right.
It's varying on different sites and different locations, but most of it's just exported onto.
So for people here, I mean, curtailed energy can be, like in a wind farm, for example, I know it can be as much as 30% of the capacity of that wind farm. The grid just doesn't need the power when the wind's blowing, but guess what? Data centers can soak up that energy.
And in our setup as well, if the data center is using the power, when it's not using that power, the rest is actually exported, so it's perfectly balanced.
Very interesting. And are the carbon credits related to curtailed, or is it?
No, it'll be per kilowatt of consumed power. It'll be different to how that value gets to the end customer, but effectively, whether it was a GPU hour or it's a service, it'll be accredited to each kilowatt of consumption.
Got it. So, and what are some of the business models that you've seen for selling heat? You guys have experience beyond data centers, obviously.
Yes.
Data centers is kind of like new for you, but what are some of those business models that you've seen?
So, in places where you don't have a district heating network, you have a possibility of reusing the heat yourself. And in this case, you lower your own energy bill. Right? So that is a business case in itself. You might do the investment in the first place of the system and the setup, and then you consume that energy. We've seen it in hospitals, and we see it in various locations and in various industries. You see it in supermarkets as well. So it's basically whenever you have a high output of heat, you can mainly capture it and reuse it. And then of course there are not endless, but very close to endless possibilities of this. The importance is that you have a plan before you start. Are you going to reuse it yourself? Because that's one business case. Or are you going to position it into the grid? That's a different use case. Or do you have a significant distant off-taker of it? You might be in a close vicinity of a company that could use that heat. And here you can create a collaboration for them to be the off-takers of your extra heat.
Have you seen heat recovery in like hot climates, someplace like Singapore? I think there are use cases still for heat, even in hot climes.
Yeah, because...
Yeah. We are seeing that, for example, in countries like India. You can think India, they reach temperature peaks like 52 degrees in Delhi, last summertime, okay. But there are a lot of manufacturing operation, and on the shop floor, they need heat, they need hot water. Whatever manufacturing process, definitely, automotive, space industry, airplane industry, whatever it is, they need hot water. It's not only dedicated to Nordics country where they need heating system all over the year,
Yeah, absolutely. And do you guys know how carbon footprint gets calculated when somebody is reusing the heat? Is it opportunity cost, reduction?
So it's definitely counting towards scope 3.
Okay.
So in this case, it's positive on the reporting, and we are doing a collaboration on the energy emissions reporting, where you do have information from our heat recovery system into this, and that becomes part of the reporting.
Yeah, and this is what was lacking, for example, from the Green Grid. You know, the Green Grid issued the first KPI that was a PUE, very well known, and everybody's talking a PUE, how to increase, not to increase, how to decrease, how to optimize the PUE. But PUE is an antique debate for me, you know, because PUE, what to do with the PUE now? Everybody knows how to design and build a data center that will be reaching a very good PUE. But as I said, you can run 100% on diesel generator. So new KPIs are really worth implementing. And in this field, for example, the new one that will be and also it's about how to calculate it, but it's another debate. So the ERE, the energy, you know, reuse element. So how you reuse the energy is definitely at stake, you know.
And that's part of the EED now.
Yeah,
right?
This is part of the EED, and you can even reach something that looks like completely, you know, out of the atmosphere. That is a PUE that will be less than 1, you know, because typically how to reach a PUE that is less than 1. So if you take into account this ERE, you come into a new kind of dimension. This is what we call the negawatt, you know, the negative watt. Because all the energy that you will capture and re-inject in another system, this means that you will not spend energy to heat your building, to heat the district, etc., etc. So definitely, yes, we could, with this ERE, reach a PUE that is less than 1.
Very, very interesting. And quick question, I think we actually have a business arrangement at our Customer Innovation Center in Geneva, correct, for the heat?
Yeah.
How are we selling that heat to our landlords? How does that work?
Not really selling it to the landlord, but we are offering it.
Donate.
You know, as a force for good. We are offering the heat. We are on a campus in our CIC, Customer Innovation Center in Geneva, and the heat that is getting out from the data centers there, we are using it to heat the campus restaurant. Okay, but this is a good use case because all our customers visiting the CIC, we all end in the restaurant at the end of the day, you know? So we show that the restaurant is heated by the energy coming from the data center. And also very important for them, they are growing organic vegetables and fruits, you know, in some greenhouses, and those greenhouses are heated by the data center. So this is also, by the way, a very interesting use case, you know, greenhouses to grow vegetable and fruits, you know, because this consumes a lot of energy, and all agricultural use cases are definitely also at stake when we talk about heat recovery and heat reuse.
And that's a modest data center we have at the CIC. What is it, 500 kilowatt or it's less?
Yeah, it's quite small, 500 kilowatts. But it's always very, not to say funny, but interesting when we see our customers visiting the CIC because we got a big screen, you know, where we got our EER, you know, with the digital twin and so on. And just to give an equivalent of that, we just show with the heat recovery how many pizzas we are able to cook, you know, without consuming a single kilowatt hour, you know, or any ice cubes we are producing, you know, every year for free. Yeah, with heat recovery. So, yeah, but I mean, makes sense, definitely, to show whatever use case. It's not only about heating a building.
Right. And I think we even have partners who have found heat consumers. And I think this is our partnership, like with Deep Green, for example, where they've actually gone to the trouble of finding heat consumers and finding data center leases at those spaces. So,
yeah, and you are reaching a point also. We need definitely to think larger. And when we are talking about the new directive, okay, you will oblige, for example, in Europe, all the data center to recover the energy. Okay, but what to do with that energy, you know? So, for example, big hyperscale data centers, you know, 100 megawatt of it. So if let's say the public sector, I mean, if the government are not investing massively, for example, in district heating system. This is something very commonly in use in Nordic countries. I know, even in UK, for example. But what about, I know perfectly well the case of France. There is only one poor single loop of district energy, you know, in Paris, Marne-la-Vallée, where you got Euro Disney, you know. But this is because Euro Disney, as a private company, you know, they invest in this loop, you know. It was not an investment from the government. So the governments have to invest massively in infrastructure to reuse this heat. You cannot finger point the data center being the new devil, you know, consuming all the energy, forcing them to recover the heat. They are willing to recover the heat, but what to do with this heat? 1 megawatt of heat. What do I do?
That's a lot.
You know?
Yeah. Swimming
They
pools.
cannot, okay,
Yeah.
they can heat their, I don't know, 500 square meter, 1,000 square meter of office.
Yes.
Okay, what else?
Yes, exactly, exactly. So Mark, in terms of your sites, how many sites do you have now for Carbon3?
We've got 45 sites across the UK, and we've just we're always on the lookout to expand that.
And then what's your standard setup for us? What are the standard services you're providing from those sites for customers here? It might be.
As in, so actually they're pretty much industrialized sites. So there's no sort of customer. That's another one of the resilience tick boxes. A lot of them are in locations where you don't have a high footfall of people. You've got it's hidden. It's secure. It's sort of that off grid. You know, we're grid connected.
What sort of network connectivity do you offer?
Yeah, so with the existing sites that we've put out, we've gone for dark fiber connections. We've highlighted areas that we're looking to. I'm not a network specialist, as you can probably guess. He is over there actually, but we're highlighting areas that are suitable for those, rather than just it's not going to go on every site.
Got it. So I think we've covered a lot here. So we've got a way to get energy. It's either curtailed energy, behind the meter energy, clean energy. We got a way to take the heat we're generating with our data centers and reuse it someplace. So we're getting deep into like not only being clean, and we're getting to deep megawatts, as you guys call it, right? So there are options that are likely to be much more pervasive in the future for addressing how you get to a much cleaner IT footprint. And Pascal, I think the last question I'll ask you is, for people who have an existing estate, say 7 or 8 large data centers, they're not ready for the AI, even 50 kilowatts a rack type infrastructure. What is a successful roadmap approach they should think about for everything we've been talking about today?
So several kind of work stream they can launch. This is either, for example, to retrofit one part of the data center. This is really feasible, and including heat recovery, it perfectly makes sense. With a heat recovery module, we can do that. So implementing what we call adaptive cascade cooling, so that we can reuse the existing cooling system in order to implement on top of it also a warm water loop for direct liquid cooling. So retrofitting a data center, we have several use cases with that, you know, including areas like in Singapore or in Germany. We are doing a lot of projects currently with that. But then, I mean, the fastest growing data center market currently, this is definitely the modular data center. It's not only at HPE, and I manage this business, I can guarantee you for the last 5 years, this is 30% growth every year. 30% growth every year in the modular data center business. So this is definitely the perfect fit because of speed, because of energy efficiency, because of modularity, flexibility, and because, of course, of cost. This is definitely all the KPIs to take into action when taking a decision. And yeah, by the way, I mean, now you got to consider that for those AI use cases. Who knows, for example, when the next refresh, IT refresh of the AI use case will happen? Will happen in 3 years, 4 years from now? So what will be the IT infrastructure in 3 years, 4 years from now? Okay, so nobody can say, even us, we cannot say in 4 years. We can say in 2 years, 4 years, right. We cannot say, okay, definitely. So the purpose of that is that since this is a modular approach, the IT module can be considered with the same life cycle as the IT part of it, meaning that you can crane it off in 3 years, 4 years, and then put together the next one for the next IT generation. You can keep the facilities, okay, but you will have the brand new IT module definitely fitting with the brand new IT infrastructure.
And you can recycle these pods.
And of course, and we are doing that every day.
Yeah.
I mean, we are not getting to the rubbish, you know. It's recycled, so this is a second life, a third life, you know. We retrofit them, definitely, yeah, all good for the planet.
Wonderful. So I'll just close with that. First of all, I want to say, our panels are available. We'll be out in the hall, so we can clear out space. Please come ask questions if you have any. And then very quickly, right, there are other related sessions you can see on here and the demos that are out in the demo area on the Mod Pod and energy and sustainability reporting, okay? And you'll see Pascal again at a Meet the Expert session, so please come grill Pascal some more.
At 4 p.m.
4 p.m.
Meet the Expert Theater.
Yes.
Upstairs.
And your feedback matters a lot, so please, if you could go back and provide feedback on this session, unless it's bad, okay? So anyway, thank you so much for coming. Everyone here is available for questions, and I think our time is up. Thank you.